Good morning, everyone. Myself Gautam Sharma, and I welcome you all in a Sapiens Education. For any details, you can visit our website www.sapienseducation.com. So today I am going to teach you about the laws of motion. So I will cover the topics of Newton's first law of motion and inertia. Basically, we will discuss about this thing. Okay, and it's the first part of the laws of motion. So what is Newton's first law of motion? See here, and in a kinematics, our concerns was to describe the motion of a body without knowing the cause of the Newton's law of motion, and we will study about the cause of motion. Okay. So first of all, I will describe about force. What is force? Force is an external agent. Force is an external agent capable of changing the state of a rest or a motion of a particular body. For example, there is a body. Okay. There is a body. Suppose this is a body. Okay. And if it has some state, it has some state of either rest or either in a motion. So there will be any type of things. There is any state, or it is moving in a single direction. If you want to change the state of this body, then what you need to do? You need to apply something from an externally. Okay, if you are sitting, then you will be in a sitting position only. There will be no motion. Okay, so for force is an external agent capable of changing the state of a rest or a motion of a particular body, and it is a vector quantity. It is your vector quantity, right? So force is applied in a particular direction, so it is called as vector quantity. Force is called as vector quantity. Force can be exerted between two bodies without in a contact. So there may be lots of things. For example, there is a gravitational force where an force applied by the gravity is not directly contact, but some force are applied with the contacts. For example, there is a body. And if you want to move the body, and we can tug or apply a force with the help of any string. Okay, so there may be a contact force or there may be a non-contact force. So gravitational force and electrostatic force are non-contact force, and other force are of the contact force. Okay. Now Aristotle fallacy. There was a Aristotle's fallacy. What is Aristotle's fallacy? Aristotle's fallacy. According to Aristotle, external force required to keep the body in a motion. Till now, we know that for making a body in a motion, we required an external force. For example, a body is moving at a speed of 10 meter per second. So it means that as per Aristotle or any other earlier scientists, they note that always we need to require a force for making an object in a constant speed. But after the conclusion of Newton's first law, we come to the conclusion that not for a constant force, for a constant motion, we don't require any type of, for a constant motion we don't require any force. Okay, so this was the earlier, as per the Aristotle, we always required a force to keep a body in a motion, but after Newton's laws of motion, it was wrong. Okay, so I will teach each and everything step by step. One important topic is your what is point mass. Point mass. What is point mass? Point mass. Point mass is not just like it is a dimensionless or a very small object. No. If we want to describe a point mass, we need to say that an objects are being focused and it's compared with its motion. For example, a train is running between two stations A and B. So a lots of distance it has to be traveled. Okay, so this is called train can be considered as a point mass. Okay, so object can be considered as a point mass if during a motion in a given time it covers a distance much greater than its own size. So any motion, if an object is in any type of motions, if an object is in any type of motion and it can cover a large distance, for example, either it is a train, either it is in the earth is also considered as a point mass when it is compared in a solar system. For example, sun is there, earth is there, so earth is covering a very large distance, so earth can be considered as a point mass. So point mass does not depend on a size. It is comparable to its motion. As compared to the motion of any object, its size should be smaller, then it is known as point mass. Okay. Now I hope you all have understood point mass. Okay. Now let us consider about inertia. What is inertia? Very important. What is inertia? Inertia. Inertia means resistance to the change. This is the property of a body due to which a body opposes the change of its states of itself. For example, an object is at this position, okay, and it is at a rest. It is at a rest. So it won't be in a motion, and it won't try to be in a motion. If I will apply a force, then only it will be in a motion, okay, but it will resist my force. So the every body has a property to resist the change in its state. For example, one example we may give. Let us consider an object is there and it has motion of 10 meter per second. I want to make its state of a 10 meter per second to 0 meter per second. So I need to apply a force. Then body will resist this force. Body won't try to change its speed from 10 meter per second to 0 meter per second. It means that body always try to resist its change. So this property of a body is called its inertia. Inertia of a body is measured by the mass of the body. More is the mass, more will be the inertia. For example, if there is a heavy object and there is a smaller object, which object will try to resist very large? So definitely this large body which has more mass will try to resist. If I will apply a force of 10 Newton here and if I will apply a force of 10 Newton here, so in both the case, this body or large body having a large mass will resist more. It means that it has more inertia. That's why inertia is proportional to the mass. Inertia is proportional to the mass. I hope you have understood inertia. Okay. Now inertia can be categorized in the different forms. Okay. Inertia can be categorized in the different forms. See, heavier body, greater the force required to change its state and hence greater is the inertia. Inertia is unitless. Inertia is dimensionless quantity. Okay. Two body of equal mass, one motion and another rest, has the same inertia. So inertia does not depend upon the motion, it only depends upon the mass of the object. Okay. Now I will discuss about the four types of inertia. Okay. I will discuss about four types of inertia. See, inertia of rest. Inertia of rest. From this diagram, we can infer that if this bus suddenly starts moving in a forward direction, but earlier the body, this main has an inertia of rest, but due to sudden change in the motion, so main's body will try to be in a rest, and that's why it start falling back. Okay, so this is the inertia due to rest. Now inertia due to motion. For example, this you can see this person is driving a car and he is earlier in a motion, and motion has suppose velocity of 10 meter per second. Okay, but suddenly when he applies a brake, what will happen? When he applies a brake, what will happen? What will happen? When he applies a brake, then what will happen? Try to understand. When he apply a brake, see what happens, and person bend forward. Why? Person bend forward. Why? Because person was already in a motion, but suddenly car stops. So car will be in a rest, but person will try to be remain in a motion, so it will move forward. Understood? This is the inertia of motion, because person's body has earlier inertia of a motion. Now third is your inertia of direction. Okay. Now see, when you are sitting in the car and suddenly car move try to bend or try to move in a some certain direction, so your body will try to be remain in that direction. So that's why when your car is moving in a circular motion, so your body will try to be remain in certain direction. Okay, so this is called inertia of direction, or inertia of rotation also we can see here, inertia of rotation also. Okay. Now I hope you have all understood about inertia. Inertia is the measure of mass. More is the mass, more is the inertia. Okay, and inertia is the property due to which it resists the change of its state. If it is in a state of a rest, then it won't try to be in a rest. It will be try to in a rest. If it is in a motion, then it will try to be remain in a motion. And if it is in a particular direction, if it is an object is moving in a north direction, so it will try to be move in a north direction. If you will move in a south direction, it will resist. Inertia of rotation, if an object is moving being rotated, so it will try to be in a rotation until and unless an external force is applied. So this is the property inertia. I hope you have understood. Now Newton's first law of motion. See what Newton's first law of motion statement is. See, Newton's first law of motion. Every body continues to be in the state of a rest or a uniform motion in a straight line unless compelled by some external forces. Okay. For example, see, if a body is moving with the velocity of 10 meter per second, so it will be in a 10 meter per second only. But is it practically possible? As we know that in our earth, when we throw a ball with the initial speed of 5 meter per second, after a certain distance its final velocity becomes 0. But as per the Newton's first law, if its speed is 5 meter per second, it should be remain in a 5 meter per second, as there is no external force. So see, try to understand the definition. Every body continues to be its state of a rest or a uniform motion in a straight line unless compelled by some external force. See, this laws applies on the earth only. Earth, not only earth but universe also. Suppose you are in a universe, then you throw a ball in the universe. Okay, you are in a space. Suppose you are in a space and you are in a space and there is a whole everywhere there is nothing else. You are only there. If you will throw the ball with the 5 meter per second, what will happen? So it will continue to be in a 5 meter per second. Okay, and in the universe. But it is not in the same in the case of the earth. Why? Because there is an external force. See, Newton's first law clearly states that until and unless compelled by some external force to act otherwise. So when you throw a ball in the playground, what happens? There is a lots of resistance of the ground which try to stop it. It means that it changes the status of the motion. So as per Newton's first law, unless and until if there is no external force, so it will try to be in that state only. If a body is in a rest, so it won't suddenly start moving. Why? Because it requires some external force. If body is coming in a single direction, so it will be in a single direction only. If it is coming in a south direction, so it will remain in a south direction until and unless an external force is applied. So if you want to change the direction, it means that you want to change in inertia. It means that you need to apply a force. Understood? So if the net external, see here, and whenever you apply a force, then it means that there is a change in a velocity, change in a state, change in a direction. And if it happens, it means that there is a acceleration. So see, very important point. If the net external force on the body is zero, its acceleration is zero. If acceleration can be non-zero, then net external force of the body is there. So whenever force is applied, there is an acceleration. Whenever no force is applied, no acceleration is there. Understood? So if net force is not equal to 0, then acceleration is also not equal to 0. And if net force is equal to 0, then it means that net acceleration is equal to 0. So this is the Newton's first law. So try to remember this formula. Okay? See, I will show you one example. Now, so see, we try to remember this formula. F net is equal to 0. Then acceleration is equal to 0. If net force is not equal to 0, then acceleration is not equal to 0. Understood? Now you can see a person standing in a moving bus suddenly feels a jerk in forward direction. When bus suddenly stop, why? Tell me. Why this happens? See, when a bus is moving, so what happens? Bus is in motion. So body is also in a motion. Suddenly bus stops, but the body won't stops. Understood? So body will try to move forward. After a while, body will stop because there is a friction force. It means that here body in a motion will try to remain in a motion. Similarly, when a body, similarly what happens? See, when a bus, similarly when a bus starts moving, what happened? Body is already in a rest, but suddenly bus is moving, so body will try to remain in a rest. That's why our body suddenly gets backward motion or suddenly gets move backward. This is the main reason, and this is clearly explained in Newton's first law of motion. So common forces in a mechanics are weight. Weight will always act in a downward direction. See here, weight will always act in a downward direction. Weight is equal to mg. Okay. Reaction and normal force. I am talking about reaction or a normal force. See here, whenever object is placed on a object, so it will give a force of mg, that is weight, and in return it will react, that is equal and opposite force, that is known as reaction force, or R equal to mg. Here also R equal to mg, but in downward direction it is your mg, so in this direction it is your mg cos theta. I will discuss this thing on further topic. Okay, I hope you have understood till now. So till now first law of motion is finished. Thank you everyone for watching this video.